Hi guys, welcome back to my channel S Chemistry. My name is Sonal and today we are going to understand the mole concept. Okay, now before you understand mole concept, a very crucial part in physical chemistry. Okay, before we understand what is mole concept, we have to be clear with the definition of one mole. Okay, so if I ask you what is one mole, or how will you define one mole, what is one mole in terms of chemistry, okay, how will you answer that? Now before we do that, let me just give you some daily life examples. Okay, consider a person is going to a shop in order to purchase these particular items. Okay, so we are looking forward to purchase 1 kg apples, okay, 10 grams of sugar and 5 dozens of oranges. Okay, now over here you can see that kg, gram, dozens, okay, these particular things that we have written over here, right, they are nothing but units. Okay, kgs, grams, dozens, ml, liters, okay, all of these are actually units, right? Units of what? Units of measurement. That is how we use these units in our daily activities, in our daily routine, right? For example, we know that 1 dozen equals to 12 entities. Okay, 12 entities meaning count, right? 1 dozen equals to 12 entities. Simply, if a person is going to purchase 5 dozen of oranges, that means it will be 5 into 12, as in the count of oranges in the purchase will be 60. There will be 60 entities of orange present in 5 dozen. Okay, so the person will obviously purchase 60 oranges. Similarly, in the field of chemistry, in the subject of chemistry, we have a unit known as mole. Okay, like we have 1 dozen equals to 12 entities. Similarly, 1 mole equals to 6.022 into 10 to the power 23 entities. The count of a given substance, when we say 1 mole of a substance, that means it will contain 6.022 into 10 to the power 23 entities of that particular substance with which we are dealing. Okay, now entities, let's try to break down the word. Since we are dealing with the subject chemistry, what do we understand by entities? Okay, so entities in chemistry are basically particles, okay, which can sometimes be atoms, or they can be molecules, or they can be charged particles, which are nothing but ions, right? Cations or anions. Okay, for example, I have written a few things over here which we will discuss in some time. Before that, let me tell you another important thing. 1 mole of a given material or a given substance will always correspond to 6.022 into 10 to the power 23 entities. That is 6.022 into 10 to the power 23 atoms, molecules, or cations or anions. Okay, it is a fixed number. This particular number is known as the Avogadro's number. It is a constant value and it will always be equal to 6.022 into 10 to the power 23. Okay, let's take a few examples to understand the same. So let me break it down for you. Okay, let's take an example of 1 mole of hydrogen atoms. Okay, I'm specifically dealing with the term atoms. Okay, 1 mole of hydrogen atoms will equal to, or it will correspond to 6.022 into 10 to the power 23 atoms of hydrogen. That means when I say 1 mole of hydrogen atoms, it will contain 6.022 into 10 to the power 23 atoms of hydrogen. Similarly, if I say 1 mole of dihydrogen molecule, see the change that I have made? Here I was dealing with an atom, a single atom, right? Here I'm dealing with H2, which is a molecule, a diatomic structure, right? So 1 mole of dihydrogen molecule will contain 6.022 into 10 to the power 23 molecules of dihydrogen. So when you're taking atoms, you get the answer in terms of atoms. When you're taking molecules, you'll get the answer in terms of molecules. So 1 mole of H2 will be equal to 6.022 into 10 to the power 23 molecules of H2. But in the same given example, if I want to calculate the atoms, I can do that as well. Okay, for that I need to have a basic understanding that a dihydrogen molecule, H2 molecule, is made up of two atoms of hydrogen, right? So if I need to know the number of hydrogen atoms in 1 mole of H2 molecule, it will simply be 2 multiplied by your Avogadro's number, that is 2 into 6.022 into 10 to the power 23 atoms of hydrogen. Okay, let's sum it up. 1 mole of dihydrogen molecule is 6.022 into 10 to the power 23 molecules of H2, and that also equals to 2 into 6.022, that will be roughly around 12.022 into 10 to the power 23 atoms of hydrogen. So double the number of your molecules. Okay, double the number of molecules will give you the number of atoms. I have put forward a question. How many atoms are present in 5 moles of silver? A very, very basic question. How many atoms are present in 5 moles of silver? Okay, so we have our standard equation, which I've just shown you guys. 1 mole will always contain 6.022 into 10 to the power 23 atoms of silver, since we are dealing with silver. Okay, and the question is also asking for atoms. So if 1 mole is this much, okay, that means you can use your basic cross multiplication method. Okay, if 1 mole is so much, that means 5 moles will be x. X is something that we have to find, right? So you basically just have to cross multiply, isn't it? X into 1 will be equal to 6.022 into 10 to the power 23 into 5. Simple cross multiplication. Okay, if you just try to do this further, you will get the answer roughly around 30. Okay, around 30.11 into 10 to the power 23 atoms of silver. Okay, so 30 into 10 to the power 23 atoms of silver are present in 5 moles of silver. This is how you apply the concept of mole. Let's move ahead. I have put down another question for you all to try. Again, a very basic question. So if you all have understood the concept, you can pause the video over here and try to solve this question before I actually give out the solution to it. So this is a solution to that problem. Very simple question. How many moles of copper are in 6 into 10 to the power 6 atoms of copper, right? So earlier I asked for the number of atoms. Now I'm asking for the number of moles. Okay, so standard equation, 1 mole is the Avogadro's number. So x moles will correspond to 6 into 10 to the power 6 atoms, which is asked to us in the question. You do your simple cross multiplication. I hope when I say cross multiplication, I mean this, like multiplying the opposite terms. Okay, your final answer will be roughly around 0.99 into 10 to the power minus 17 moles. Okay, minus 17 because we'll have 6 minus 23 in the power calculation, and that will come up to a negative value of 17. So 6 into 10 to the power 6 atoms corresponds to 0.99 into 10 to the power minus 17 moles. Okay, so well, let's take the last question for this particular video. You guys can again pause the video, go ahead and solve it, and then come back and check for the solution. I'm going to proceed with solving this particular question for now. So how many atoms of oxygen are present in 2 moles of dioxygen? So you can see that atoms are asked, but the data provided to us is in the form of a molecule, right? Atoms are asked, but what is given to us is a molecule. So how to go ahead with this? Okay, start with your basic understanding. 1 mole will correspond to Avogadro's number. Let me tell you, 6.022 into 10 to the power 23 is also represented as capital N with a subscript A. Okay, Na, which is a symbol for Avogadro's number. Okay, so 1 mole corresponds to 6.022 into 10 to the power 23 molecules of dioxygen, O2, right? Na is nothing but 6.022 into 10 to the power 23 molecules. Okay, now if these are the number of molecules, okay, in O2, O2 as a molecule contains 2 atoms of oxygen. That means it will be 2 into Na atoms of oxygen. Yeah, okay. 1 mole, fine, I'll write it over here also. 1 mole is Avogadro's number of molecules of O2. Okay, but in terms of atoms, it is 2 times, because when we say O2, now it is a diatomic molecule. O2 is made up of 2 atoms of oxygen. So now this particular equation will be our reference equation, the standard reference. Okay, so if 1 mole corresponds to 2 times Ne, yeah, therefore 2 moles, what is asked to us in the question, will correspond to how much, correct? So it will be 2 into 2 into Avogadro's number, which is 6.022 into 10 to the power 23, that will correspond to x. So finally x will be around 2 2s are 4, 4 6 are 24, around 24 into 10 to the power 23 atoms of oxygen in O2 molecule. So the data was of a molecule, question was of atoms, and this is how you do the conversions. Okay guys, so with that I'm going to stop this video. I hope you understood the ground level explanation of 1 mole in chemistry. Thank you so much for watching. If you guys did like this video, please give this video a thumbs up and follow for more. Subscribe to my channel for such videos ahead. Take care. Bye bye.